Here's the solution to question number 5 of practice test number 2. So we notice we're given a lot of facts. First of all, we're given the time in seconds, and then we are given the distance traveled in meters, and then we are given the velocity, meters per second. Okay, so he's riding a unicycle back and forth along an east-west track. Okay, it's differentiable, and B is the position on the track in meters from the western end of the track. So in other words, at time 0, he is 100 meters from the western end of the track. Then he's 136 meters away. Then he's 9 meters away. And then he's 49 meters away from the western end of the track. Okay, so we need to make sure we understand it. And then meters per second. Good. So part A, use the data to approximate Ben's acceleration. Well, we know that acceleration is the slope of velocity. So at time 0, at time 5, right here. So to find the slope of velocity, I would take the change in y over the change in x. So for part A then, it would be velocity at 10 minus velocity at 0 all over 10 minus 0. So the slope of velocity is acceleration. And so you would get 0.3 over 10, which is 0.03. Now make sure you get the units right. So if this is acceleration, it's going to be meters per second squared. Okay, now let's go into part B. So part B then says that we have to be able to interpret the meaning of this. Okay, now I'm trying to erase again. Here we go. It's not working. So I'm going to go to my new page. So interpret the meaning then of 0 to 60, absolute value of velocity dt. Okay, well we know when we take the integral of velocity we get the displacement. Well, when we take the integral of absolute value, this would be the total distance traveled, and make sure you use units and time in this. The total distance traveled, and what are the units? In meters. Okay, and who's driving that Ben rides? You can say from t equals 0, Ben rides from t equals 0 to 60 or something like that. Okay, from t equals 0 to t equals 60. So you must give all of the units to get a full point there. Now next they say use a left Riemann sum to find this total distance traveled. Oops, 0 to 60, sorry. So we have to use a Riemann sum. Now Riemann sum just means base times height, okay? And so when we're going to do this, we're going to multiply to find distance. Remember, distance equals rate times time. So I'm going to multiply the rate multiplied by the time. Well, the first set of time is 10 minus 0, which is 10. And if it is going to be a left Riemann sum, I take the first rate, which is 2. Plus, now the second interval of time is 30. And then the second rate is 2.3. And then the third distance is, in time, change in time is 20, and the rate is 2.5. And I do the mathematics, and I end up with an approximation of 139, what? Meters. It's distance traveled. Great. Okay, now let's go into part C. So part C then says, now let me erase this first. Let's see if I can do that. Okay. Nice. Okay, going back to the Pemo. So part C then is we have to find a time when Ben's velocity will be 2 meters per second. Okay, does that exist in the interval from 40 to 60? Now many of you, what you did is you looked at the velocity line and you noticed that between 40 to 60 of velocity, you had 2.5 to 4.6. So then you use the intermediate value theorem to say that 2 would not exist because 2 is not in this interval. Okay? Well, you're right. The intermediate value theorem does not prove that 2 does not exist. But we want to prove that 2 must be, or is there a time where 2 must exist? Is there another theorem that talks about slope? Well, yes, there is. There is the mean value theorem. So the mean value theorem says that there will be a point that exists such that when you take the change in y's, so the b of 60 minus b of 40, then that would equal to 2. If that happens, if this ever equals 2, then that means that there will be a point in time when I'm going 2 meters per second. Well, when I do the math on this, b of 60 is 49, and then b of 40 is 9 all over 20, so 40 divided by 20 is 2. So then by the mean value theorem, I can guarantee that there will be a rate of change at 2 meters per second. Okay, last of all now, let us go to part D. Okay, let me erase this. And part D says that we know, they give us this function, L of t squared is equal to 12 squared plus b quantity t squared. And what does L of t represent? It represents a light, the distance of the light between Ben. Okay, now we want to find at what rate is the distance between Ben and light changing at time equals 40. So I need to find the derivative of light. Well, first of all, before I take the derivative, I need to take the square root of both sides. So I have a function in terms of L of t. So L of t would equal, I'm going to write this in power form because we all know that's much easier when I'm taking derivatives, to the 1/2. Now I have to be very careful here because this is a chain rule galore. Okay, so when I take the derivative of this, I first take the power and bring it forward. So I have 1/2, 144, plus the quantity b of t squared. And then I subtract 1, so I get negative 1/2. Now chain rule says I have to multiply it by the derivative of the inside function. Well, notice that's a chain rule too. Well, the derivative of 144 is 0, but then I'd have 2 times b of t, and now it's just to the 1 power. And then I have to take the derivative of the inside function there, which would be b prime of t. So now I have the derivative of L of t. And now I know b of t and I know b prime of t, so I'm going to replace those values with the given information. So I'm going to have 1/2, 144, and b of t is 3. So it's 9, so it's plus 9 squared to the 1/2 negative 1/2 power. Okay, times 2 of b of t, and b of t at 40 is 9, times 2 of the derivative at 40, which would be 2.5. Okay, wait, did I do that right? Oh no, not 2 times it. I'm sorry, my mistake there. I thought I did something wrong. Okay, just be times 2. Okay, now let's start simplifying my work here. So it's going to be 1 over 2 radical. Well, 144 plus 81 is 225. Plus, and then I have 2 times 9 times 5, okay? Not 5 times 2.5. I've been doing math too long. And so the square root of 225 is 15, times 2 is 30. So I have 2 times 9 times 2.5 over 15 times 2, which is 30. And then I could reduce and simplify this, and I end up with 3/2. Now 3/2 what? What are the units? Because I'm finding the rate. So then it would be meters per second. Phew! That's the end of question 5.